Hey, in this video, we're going to be going through all N8N functions. As of the time of this recording, there are 106 of them, and they're broken down into the following categories. We have string functions, number functions, array functions, object functions, and Boolean functions. As somebody who's scaled an automation agency to $72K a month, realistically, I find myself using some of these more often than others, and I'm going to cover them when we get to them. But either way, by the end of this video, you're going to know all N8N functions, and they're going to make you a substantially more effective and faster builder. Let's get into it. Okay, let's get building. I have an N8N workflow open over here called all N8N functions. I'm going to click add tag and go down to N8N course just so I can help organize it a little bit. And all we have is we have a start node. This begins a flow when I click test workflow down here. So give this a click, you'll see that it's just turned green. This just tells us that this has triggered the flow. Peculiarity of the start node is, when you click it and when you get it going, it doesn't actually output any data, it just starts the flow. So obviously, if we want to do something here, we're going to have to add another node. So let me click on that right little plus sign. And then the nodes that we're going to be using in this video, I'm going to be using pretty gratuitously. They're called the edit fields node. And the edit fields node, for anybody that's coming from maybe a different no-code editor, especially something like make.com, you can just think of this as a way to set variables, rename fields, and that sort of stuff. So I'll go down to edit fields over here, give us a click. And now, we have the start node on the left, and that's the input. And then in the middle here, we have an edit fields node with a couple of different modes. There's manual mapping and there's JSON. Basically what this allows you to do is if you give this a click, you can define your own variables here. And if I click test step, you'll see that we now have a new variable accessible to us in the output called hello world. Now, what I'm going to be doing is I'm going to be using the JSON option here, and I've already created a bunch of JavaScript that I'm just going to be using for the purposes of running through all the functions. So this is what the object looks like. We have a string called hello, number 3.5, an array with names of Sarah, Sally, and Stephanie, an object, and this object has some parameters like first name, last name, height in centimeters. Then we also have a bool, that stands for Boolean, and that's just set to true. I'm doing this because these are all of the different function types that we're going to be working through in the rest of this video. And so I just wanted an easily accessible way for us to get all of these and then do cool stuff with it. So if I zoom out a little bit, just because N8N looks a little ugly when I'm not zoomed in, I can now add, let's just give this a quick rename. Let's just say set example JSON. And what I'm going to do is I'm going to go and do another edit fields. And this edit fields is where I'm actually going to be mapping, the output. So I'm going to call this output. And then for now, we'll go off of a string data type. And what I'm going to do is I'm just going to drag this string into the value. And now we have access to it. Now, the way you use functions in N8N, as I'm sure you're probably already aware, but just to reiterate, is all you do after you've selected a variable from an input and it's turned green, like this one here, all you need to do is just click the dot. A period then opens up this function editor, and now we have access to tons of stuff. So you can see there's some suggested functions here. This is just because, well, N8N gives you a large library of functions that you can do stuff with. In practice, you don't actually end up using the majority of them. But I'm still going to run you through every single one of these for completeness' sake, and then if I touch on something that I actually use pretty often, either for my own workflows or workflows that I've seen other people use, then I'm going to mention it. Okay, great. So let's start with the very first one. Now, if you remember, if I click back here, this turns green and we see a result down here to hello. If you remember, the value of this string right now is currently hello, okay? So keeping that in our minds, what we start with is the includes function. The way that the includes function works is basically we can use this to search within a string to see if something includes a substring that we're looking for. So right now we have hello. And what we're basically saying is, does hello include what I'm about to write inside of here? So if I write H, the result will be true. But if I write something like X, you'll see the result will change to false. Keep an eye on this result panel because this is going to be your best friend anytime you're manipulating functions because most of the time it'll give you some sort of real-time feedback. So, if I wanted to see whether or not my string contains the word hell, I don't know, maybe I am very pious or something. I type hell in here, you see HELL is a 4-letter substring that is inside of hello. Obviously, this is going to turn true. But if I were to jumble up the letters, right, if I were to go LLEH, you'll see that this is false because this is reading all strings left to right. So this is a pretty quick and easy one. It's kind of useful to see whether or not something includes, obviously, if you have a very large string, you can instantly do this just to search and see whether or not that string includes just some tiny little thing that you're looking for, a mention of something perhaps. The next one I'm going to cover is called split. Now, split is something that I use basically all the time. I use it at least once a day, and I use it across a variety of no-code tools just because it's so god dang useful. Now, the way that split works is you essentially take your string, HELLO exclamation point in this case, and then you convert it into an array. And the way that you do so is you give it a character that you want to split the thing by. So let me give you a very simple example. If our input string is HELLO, let's hypothetically say, I wanted to split this into two halves. And the way that I wanted to split it was based off of the presence of the L and the L here, okay? So what I could do is I could say JSON.string.split, and then in quotes, and you have to use quote signs. If I go LL, you'll see that I've now split this string into two substrings, basically, and then plopped them in an array. Now, if you're unfamiliar with what an array is or how an array works, that's okay. We'll get into that later. But for now, all you need to know is that we've basically taken one input, and we've turned it into an array that contains two outputs, the HE and the O. If you split it based off of the presence of an L, you'll see that we are now generating an empty space. Why? Well, this is sort of nuanced, but if you look at our input over here, that's HELLO. If we're splitting based off of an L, what this is doing is it's catching the empty string in between these two L's. So hypothetically, if I wanted to split this by something else, let's say the E, you see that this is now splitting into a substring that's H and then LLO. If you wanted to do this based off of the presence of nothing, you'll see that it splits it based off every character. So this is just its default if you don't feed it in any input whatsoever. So if you have an empty string like this, it's HELLO exclamation point. And splitting is really useful just as a quick and easy way to take something, usually some sort of tabular or CSV data, and then just turn it into, an array that you can use N8N for. So let me give you a quick little example. Right now, this editor is set to $JSON.string. So we're referencing a variable from a previous, node. There's actually a little hack in N8N that you can do. If you want to create something directly in the function editor, to do so with a string, all you do is you add quotes, and then you do something like Sarah, Sally, Stephanie. Everything within these two quotes still technically counts as a string. And so you can dot index it, you can slice it into, you can use dot notation, I should say, in order to attach a function to the end of it. So hypothetically, let's say we had three names here, and these three names were just somewhere, I don't know, they're in some data source that we're scraping. Well, we can turn this into an array very easily just by adding the delimiter of comma and then space. Now, because we're going comma and then space, as you can see, we've turned this string of Sarah, Sally, and Stephanie into an array. So that's a quick example of split. Split's pretty awesome. I use split all the time. Because we just deleted all of this, we need to reselect our string. So I'm going to go $JSON, then I'm going to go .string. That's the name of the key in our JSON that we fed. And so now we have the hello again. Let's proceed. Next, we have starts with. Starts with is kind of what it sounds like. If you want to see whether or not a string starts with a series of letters, or not necessarily letters, numbers and stuff like that as well, characters, I should say, then you can just use starts with. So in our case, if we wanted to see whether it started with HELL or something like that, then this would return true. But if we wanted to instead, I don't know, let's say we wanted to see if the string started with the term by, then it would obviously be false. Similarly to starts with, as you can see, we also have ends with. And so the way that this works is very similarly. Essentially, all we're doing is we're starting at the back and we're just working our way forward. So if the hello exclamation point string, sorry, I was just getting a call there, but it looks like it went to voicemail. If the hello exclamation point string is, I don't know, exclamation point, this is obviously going to be true, right? But if it's a $, it's going to be false because we don't have a $sign present in our string. If we were instead to go ELLO, this would again revert to true. So lots of options there, and there are a lot of functions in reality that you'll find are just the inverse of each other. So if there's something for starts with, odds are there's something that ends with. If there's something for uppercase, odds are there's something for lowercase. We're going to cover all of that over the course of the rest of the video. Okay, great. There's also this other function here, which I find myself using quite often. It's called replaceAll. And so replaceAll is sort of a power function. Basically what it allows you to do is it allows you to take this string, which we have here as hello exclamation point, and we can just replace any character we want in there with another character. So let's say we're some crazy anime weeaboo. What we do is we replace the first letter, L, and we go, comma, and we replace it with W. What we're doing now is we're replacing all of the L's in this string of hello with a bunch of W's, hello, right? So we have a lot of, granularity and control there. If you look over the expression and function documentation over here, you'll see that this is the first instance in which we're now splitting this into two parts. So, we actually have two variables that we're feeding into the replaceAll function. There's a pattern, aka what we're looking to replace, and then the actual thing that we're going to be using to replace it. I could just as easily replace the term, if we just take both of these out. I could just as easily replace the term, the O, right, with nothing. And if I do that, it actually just cuts it out, just removes that character completely. So replaceAll is pretty powerful. I find myself using this all the time when I'm developing flows. And I'm glad that it's in the suggested editor up here alongside with split, because, these are the two most common ones realistically. Okay, great. Moving our way down, you'll see that there's a very interesting looking function. This technically isn't a function. I believe this is a parameter in JavaScript, technically speaking. And that's why it doesn't have the two little brackets next to it. But this is just a quick and easy way to determine the length of a string. So, if HELLO exclamation point, this is 1, 2, 3, 4, 5, 6, right? We should expect this to say 6. And that's exactly what happens when we feed in length. Hypothetically, if I were to replace this with, hey, how's it going, man? You'll see that the character length of this string is now 24. So length is super valuable. I use length all the time. I use length to determine, whether or not the input that I'm feeding into a large language model is too much, right? A lot of the time you can average out the token length of a big string just by multiplying the number of characters per word on average. And if you look up number of characters per word, the average is 4.7. And then if you want to get the number of tokens per word average, you'll see that that's something like 2 to 3. A paragraph's 128 tokens. I guess I should have said number of words per token. This ends up being about 0.75. So from there, if you feed in a string of 1,000 characters, right? What was the math there? 4.7 or something, I believe. Yeah, 4.7. So 1,000 characters divided by 4.7 is 212 words. 212 words times 1 over 0.75 gives us 282 tokens. Odds are, if you do this calculation and you get the length of your string, you're going to know that every time you call a large language model, you're going to be using 282 on average over a large enough data set, 282.6 tokens in order to do so. So, if you're not working with large language models, maybe a little bit less applicable, but there's still a variety of reasons why you might want to use length. So length is definitely one of the big boys. Okay, so working our way down the function panel here, we have base64 decode and its partner, base64 encode. Now, if you guys aren't familiar with what base64 is, you can think of it in a really simplified way. It's just a slightly different alphabet used to represent strings. If I were to zoom into this example, the letters HELLO, when they are base 64 encoded, translate to A, capital G, capital V, S, B, capital G8, and then the little equal sign. So this is basically just a way to rotate characters according to some formula, this base 64 function. And the reason why they have a function available is because a lot of servers and some web services will only accept base 64 encoded versions of the strings that you send them. This is both a security purpose, and I believe there's also some sort of compression purpose as well. But to keep things really simple, we'll start with base 64 encode. Then I'm going to feed in the thing that we just base 64 encoded into a base 64 decoder, just so you can see that they're the same thing. Okay, so if I were to attach base64 encode over to the string HELLO exclamation point, you'll see that it's very similar to the string that I just showed you guys without the exclamation point. The only difference is the last letter, I think, is an H or something like that instead of an equal sign. So as you can see, it's very similar. Now, if I were to take this string and then I were to attach another function to it, base64 decode, notice how we've basically just regenerated our initial hello string. We could do this an arbitrary number of times. I could go back to base 64 encode, then base 64 decode, and hypothetically we could make this thing, the distance from here to Mars. But as I'm sure you guys can guess, it's kind of pointless to do so. So this is sort of a niche function. I do use that function. I use one of the two functions reasonably often when I'm doing certain API calls, because sometimes you need to base 64 encode an API key or base 64 encode credentials, usernames, passwords, that sort of thing. The only thing I want you guys to take away from this, if you're unfamiliar with it, is next time, a service says, oh, you'll need to base 64 encode a string. Well, now all you need to do is just go to your string, press period, and then type in base 64 encode. Voila, you're done. Okay, continuing on down, we now get to another function that I use reasonably often, one called concat. Concat basically just allows you to take your string and then add on another string to it. You kind of think of this as like a string addition, right? You're like manipulating the string, you're sticking two strings together. So if I were to press enter here, go to concat, and then inside of quotes, I were to say space world, you can see here that my string has now changed from hello exclamation point to hello exclamation point space world exclamation point, right? The cardinal example of, you doing something cool with a computer for the first time. Now I should note that you can also feed in more than one string. So you could actually feed in an array of strings. That's why the concatenate function is kind of cool. So I could technically feed in world, and then I could go, how are you? And then you'll see that, we've now taken three strings, we've stuck them all together. The first was hello, the second was world, the third was how are you, right? The next series of functions I use all the time, and they're the extract functions for strings. So we have 4: extract domain, extract email, extract URL, and then extract URL paths. And basically the way that this works is, this is just something that allows you to pull out a domain name from a string that you supply that might include it. You can pull out like email addresses, you can pull out the whole URL instead of just a domain, or you can pull out everything after the backslash at the end. I'll show you what I mean by all this right now. So I'm going to use extract domain first. The way that extract domain works is you either feed in a URL or you feed in I believe like an email, and it'll basically tell you what the domain is. Obviously, this isn't rocket science. If I delete the hello string here, because this doesn't actually have any domain inside of it, which is why it's returning undefined. If I were instead to type something like nick@leftclick.ai, you'll see that extract domain extracts leftclick.ai. Okay. Conversely, if you were to just go leftclick.ai, it would remain the same. If you were to go https:///, it would only extract the leftclick.ai portion. And there are a variety of instances in which this is useful. A lot of the time when I'm web scraping for either myself, people pay me to build a web scraper for them, or if I'm doing it for one of my businesses, a lot of the time I'm scraping the web for strings using a regular expression that follow a certain pattern, maybe something like this. Well, this is just a quick and easy way where I could feed those strings in, and then I could extract the domain name. Because domain names and URLs are a little bit different, and a lot of the time you need a domain name for something that you don't necessarily need a URL for. So that's just a quick example of something that allows you to extract. If I were to add some spaces over here, though, you'll see that it breaks. So this does not work if you feed in like multiple or something like that. It's only really going to work if you feed in one and then you just want to extract a portion of it. But this is, comparable to you slicing the string in halves. Instead of you having to do some sort of fixed type of data processing where like you're looking for the string that occurs after the second backslash, you can just put extract domain in there and it'll basically just always get you exactly what you want, whether or not there are, 3-letter top level domain endings or 2-letter like I have over here, right? So very flexible, very nice. The second function that I'm going to show you is called extract email. So as I'm sure you guys can imagine, if you feed an email into this, it will return with said email. If I go back to that other example and go nick@leftclick.ai, right? So we see here, we're now extracting nick@leftclick.ai. What's pretty cool? If I add a bunch of other text here to the beginning and then to the end, this is different than the extract domain. Unfortunately, the documentation is pretty poor. But if I feed in a bunch of additional information, let's say I scraped a website and we just have tons of text. And then just somewhere in this text, there's one little line that says nick@leftclick.ai, okay? One tiny little line. This will extract and pull out the nick@leftclick.ai based off of like an email formatting mechanism, whereby it looks for a little string and then it looks for some @ symbol and then it looks for some domain ending. So that's really, really useful. You can use this just as your email extractor. You are going on a website or something like that. You feed in the entire string of the scraped website to this function, and then it just pulls out the email addresses for you. I think you guys could probably come up with a million use cases for something like that. Okay, let me just put this back in here because I hate when it screams at me with red. And we're going to move on to the next function, which is extract URL. So similarly, the way that URL works is a little bit differently from extract domain. In case you guys weren't aware, this is the domain name right over here. But this is the URL. So the URL tends to have some sort of, and I forget, I think this is just the protocol. And then you have some standardized delimiter, which is usually this colon and then these 2 backslashes. And then you have the domain name. Okay, that's how that works. So this will actually extract a URL based off of the presence of this. Now, if I take out the P, right, it's going to break because there is no protocol called HTTPS. But I could take out the S and that would work because there is a protocol called HTTP. I'm unsure if FTP works. Yes, FTP works. Does SSL work? No. SSH, sorry. No. Anyway, the variety of these protocols, feel free to look them up if you guys are curious what sort of URL protocols there are and sort of like URL structures. But yeah, this is just a quick and easy way to get the whole URL, which can be very useful. And then from here, what I want to do is show you the last one, which is called extract URL path. And the way that extract URL path works is, as opposed to getting the URL itself, which is everything sort of, if I put a slash here, it's everything before this line. In like the HTTP protocol, they call everything after this first slash the path. And a lot of the time, websites and services and stuff like that, they'll actually store a ton of important information after that backslash. If I show you guys what this looks like on N8N in particular, you'll see that this is my cloud account. So if I were just to make this practical, this is the URL right over here. It's https://nixarchive.app.n8n.cloud. Okay. This is well, I guess this is part of the URL, but this is like the root part of the URL. This is the protocol. This is the domain name. And then this over here is a URL path called workflow / and then I have the ID of my particular workflow that N8N uses to grab data from its server and then display it to me. So if I wanted to extract this URL path, if I just feed in this whole thing, just as an example, and replace my little leftclick.ai example, you'll see that what results when I extract the URL path is basically it goes to this backslash, and then it gives me the backslash plus the term afterwards, workflow, plus everything after, the next slash. And the way that URLs work is you can go arbitrarily deep over here. Okay, if we continue down the function list, the next one up is called hash. Now, if you're unfamiliar what a hash is basically like a mathematical algorithm applied to a string that converts it into just some big long number. The confusion with hash tends to be that the number that it generates has letters in it. So if I take this string, https://nixarchive.app.n8n.cloud, if I take this here, then if I hash it, according to their default algorithm, which I believe is MD5, you can see we get this long result here. And the reason why a lot of people don't understand these hashes and they're so scary is just because this isn't actually like a string. This is a number in something called hexadecimal. Hexadecimal is just another number system where instead of it going up to 10, it goes 0, 1, 2, 3, 4, 5, 6, 7, 9, 8, 9, and then it goes A, B, C, D, E, and F. You know how binary is 0 and 1? Well, there's technically a bunch of different number formats. There's binary, which is 0 and 1. I think there's quaternary, which is 0, 1, 2, and 3. There are a bunch of other ones, right? There's like a number system based off 5, number system based on 6, 7, 8, 9. Our number system just tends to be based off of 10. That's why it's 0 through 9. But this hexadecimal is a number system based off 16. And the thing is, we just don't have any other characters that we can use. So, or I don't know, it just wasn't convenient to invent new characters for the 10th thing, the 11th thing, the 12th thing, the 13th thing, the 14th thing, the 15th thing. So what computer programmers or scientists, the people that developed this, standardized format did, is they just decided to use the letters A, B, C, D, E, and F. So you can think of it as this. The number 3 corresponds to the number 3. A corresponds to the number 10. B corresponds to the number 11. C is 12, D's 13, 14, and then this is 15. And the reason why it stops as 15 is because we start from 0. So 0 to 15 is technically 16, different numbers. So, this is one of the main issues with people in hashing. I find, the hexadecimal just isn't really explained super easily. But essentially all that a hash does is a hash is just like an algorithm that takes a string. So if we just go hello instead of this, takes a string and then just performs a bunch of string mathematical manipulations on the value of h, which I don't know, might be 85 or something, whatever the computer programmers that came up with the standard for the numerical value of every letter is. And then it turns it into something that is just not easily interpretable by humans. The benefit of having a hash is you can then dehash this, and then you can regenerate this from this 5D41402 back into hello. And what you find hashes commonly used for, as I'm sure you're aware, are security applications. So things like hashing a password, for instance. There's this big common saying in any sort of computer security, and that's never store passwords in plain text. The alternative to plain text is hashing the password in some way. So I'm not going to go too much into this, as I'm sure you can imagine. It's very niche, and this doesn't really make you money, to be honest. I mean, if you in some computer security thing, possibly. But there are some values you can feed this, and the only real values that matter here are MD5, base 64, SHA1, SHA224, SHA256, SHA384, SHA512, SHA3, ripe MD160. These are all just different. Algorithms. So if the default is MD5, if I were to go instead and go base 64, you'll see that we've now basically done the same thing that we did with the base 64 encode function, right? But if instead we want to do SHA1 or something, we get this, SHA224, SHA256, SHA512. These tend to get longer and longer and longer the higher the SHA number thing at the end, just because this basically represents more and more complexity. So I'm going to leave it at that, but just know that there are going to be a couple of instances that may ask you for hashing at some point in the future. But as somebody that's made tons of money with no-code platforms, I don't know, in like over 100 projects, I've had maybe one require me to hash something, and that was just really briefly for like one tiny section. Okay, the next function I want to run you guys through is one called quote. It is similar in hash insofar that I don't use it a lot. All quote really does, from a bird's eye perspective, is just wraps your thing around your string in quotes, right? So if I just remove this, you'll see that it is now hello. And if I go back, it now wraps it in these quote signs. But quote can actually do a lot more than that. It's actually kind of useful when you start getting into sending and receiving data through, HTTP requests or webhooks, just because a lot of the time you have to sanitize the data that's being sent. Let me show you guys a quick example. So if there's one thing that you guys might not know, you know how earlier we defined a string with these two double quotes, and then I, wrote it down over here. Okay. Well, hypothetically, let's say somewhere in my string, I wanted to use another quote. What happens if I try and do this? Well, this breaks the whole string, right? And the reason why is because there's just some built-in logic in string parsers. Parser is just the thing that determines whether or not it's a string. But there's some built-in logic in string parsers that sees this quote, then it sees this one and says, oh, this must be the string. Then it sees that one and then that one and goes like, oh, no, this must be the string. Then it sees that one and that one. It's like, no, this must be the string. Well, how many strings are there? I can't do this. And then it just quits. So there are a couple workarounds when you're using quotes inside of a string. The first is, instead of wrapping in double quotes, what we do is we just wrap it in single quotes. And the second that you do that, like this is now technically a valid string again. But you'll see, if I just go back here, you'll see that if I try and add quotes inside of this now, with this quote function, something really interesting happens. And basically what happens is this feature called escaping. So a lot of the time, in order to prevent this exact issue that I was talking about from occurring, what you can do is you can escape a quote sign, which is you can precede it with this like reverse backslash character. What this reverse backslash character does is this just like cancels out. Actually, is this a backslash? I don't know if it was a reverse backslash or a forward slash. Anyway, that's funny. I've probably been calling one the other my entire life. But hey, might as well have that realization during filming of a YouTube video, right? So the way that this works is we are escaping this character with this backslash, with this slash character. I'm just going to use slash to like keep my sanity. And then because we have this slash in front of it, basically all string parsers and formatters will take a look at this and say, oh, okay, I can actually ignore the formatting of what happens next. So let me show you guys an example using what I did earlier. See how it says Nick says hi? Well, if I actually put a slash here and then a slash here, it's now like an acceptable string, right? But I have to do that manually every time, right? This is kind of annoying. Anytime I'm writing or adding something and I basically have to go find all the quotes and replace them. Well, guess what? That's what our quote function over here does. It just does all that automatically for us. So if you wrap the outside with the single quotes instead, then I remove this like this, you'll see that it's actually gone through and it's added in the slashes for us. So this is just a form of, I don't want to say niche, because this can be quite often, used in quite often in many applications, depending on what you like. It says up here it's useful when constructing JSON SQL. These are all, formatting conventions for sending and receiving data over the internet. But this allows you to do that. This has one parameter, it's the mark. So you can actually select the quotation mark that you want to cancel it out with, which is pretty neat. So if you want to wrap something, let's just go back to our hello example. If you want to wrap this in different quotes, then you could go single quotes like this. You could also just create whatever quote you want. So hypothetically, let's say that the underscore is my new quote character. Well, I can just have that wrap everything. Okay, let's cover the next string function. As you can see, we are making some good time. The next one here is one called remove markdown. Now, markdown is another example of a formatting convention. And you'll see that this is in large part what string manipulations are for. They take some formatting convention and they just fix it for you. So the way that markdown works, and this is kind of beyond the purposes of this discussion, let's just look this up really quickly. There's some basic syntax guide here. Feel free to check this out if you want. But this is very commonly used when you are calling large language models and OpenAI and Claude and these various services to turn text so that it's not just plain text, but actually has some sort of formatting. So here's Markdown on the left. Markdown, if you want to like create a header, what you do is you add a dollar sign. You add a number sign and then a space and then the header. If you want to do like an H2, you go 2. H3, 3. They show us what it looks like in HTML as well, which is another markup or rendering language over here. And you can see that, you know, if you want to do the equivalent thing for Markdown in HTML, you need to wrap this in some H1 tags. Markdown's a little bit more efficient. As you can see, the total number of characters used to represent the same information was just 2 here instead of 1, 2, 3, 4, 5, 6, 7, 8, 9. And so when you communicate with large language models, you know, obviously the main benefit there is, you know, the fewer tokens with fewer characters, the less money you tend to be billed, especially with these bigger APIs. So that's why everybody just tends towards Markdown in order to get rendered outputs like this. So all that function that remove Markdown does is hypothetically, if I go back to creating my own string again, and then I were to say heading 1, you'll see that this just takes out the Markdown formatting. It has a built-in parser again that looks specifically for instances of these number signs for headings. If I were to add 2, 3, 4, 5, 6, 7, 8, you know, as you can see, nothing really changes here. There is, you know, it does add a space, which is interesting, but I don't believe it adds a space on anything up to 6. Yeah, so anything up to and including 6 doesn't have a space. It does on 7. Why? Because this is no longer considered like there is no heading 7, hypothetically. And so now it says, oh, okay, this just must be like a bunch of bogus Markdown number symbol stuff. So this must actually be a real character. We're going to render the space. The peculiarities of Markdown aren't super important. Just know that you can remove it all with something like this if you want. Similarly, there's also a function called remove tags, which works, as I'm sure you can imagine, very similarly to remove Markdown. It's just all this does is instead of removing Markdown, if you go back to our Markdown and HTML comparison here, it just removes the HTML tags. So this is considered a tag in HTML. If I were to go back to my N8N function, and if I were to try and create a new heading called heading 1, what this will do is it'll jump in, it'll actually just remove all instances of this. Now, when is this useful? Well, I'll give you guys a quick and easy example, just because I think that this is something that I do often enough for it to represent, like for it to be valuable. But if I go and I do an HTTP request to my own website, notice how on the right-hand side here, I receive a bunch of HTML. That's kind of a lot of HTML, right? Now, if I go and I add another edit fields node, and then I go manual mapping, and then I go no tags, if I feed in my data, and then if I go remove tags, what you'll see is I've basically gone through, and if I just expand this a little bit so we could see big, I've basically gone through and I've taken as input all of this ugly looking HTML, then I've gotten as output just the plain text of the website, basically. And when you have the plain text of the website, not only is it a lot more token efficient when you're calling large language models and stuff like that, you know, you could run like searches over this to be easier, faster, and so on and so forth. So this is just a principle of like removing waste. So that's how you'd use that. The next function I want to talk about, if we just go back here and then select my $JSON and then go back to string, the next function I want to talk about is called replace. Now, as opposed to replaceAll, which I use a lot more often than replace, what replace does is it just replaces the first element that it sees with another element. It doesn't just replace every instance of it in the entire string. So remember how earlier replaceAll took L's, and then I replaced them all with W's, and then it was hello. Well, in this case, if I were to try and replace an L with a W, it'd go hello instead, because it's only grabbing the first one. If I switch this back now to replaceAll, it does all characters, but if I go back to replace, you see it only does one. So it's kind of neat. You know, it's a little bit niche. I mean, there aren't too many situations in which you want to replace one character and not replace all characters, at least in my experience. There's another function here called replace special cars. Basically, you know, a lot of other languages than English will have things like accents. So like en français, you have accent aigu and accent grave, right? So these are two like special formatting characters that sometimes, unfortunately, APIs do not support. What this does is it just allows you to take them out. So if, you know, I had, how the hell am I going to write that? I just realized that I don't necessarily have any of these. You know, if I was going to write something like, you know, jouer, let's go back here. What this will do, you know, if you feed jouer into replace special characters, the output is just going to be jou, like without the accent aigu on the right-hand side of this. And, you know, this doesn't just apply to French. Obviously, there's a ton of languages out there with all sorts of things above letters, like umlauts and stuff like that in German. I believe that's how you pronounce them anyway. Any Germans in my audience, feel free to roast the hell out of me. And yeah, it's just a quick and easy way to just replace those before you do an API call to a service that doesn't support them. So if you're calling a service and then it just like keeps on giving you weird error messages that you don't fully understand, and your input includes one of these characters with like an accent above or some sort of marking or symbol, call replace special cars and give it another try. I use this maybe like 5% of the time. Most APIs are pretty good now, but some of them are still sort of modernizing. Okay, the next function is called slice. Now, slice is pretty interesting. I use slice all the time. If I go and select JSON string, what slice does is it basically allows you to select a substring, but not based off of characters, but actually based off of the number of characters from the start or the finish. So we're not slicing based off of L to O. Well, I mean, like we can if we want. But I guess what I'm trying to say is we're feeding in the character order and the position, and then we're using that to extract a substring. So everything is 0 index. That just means it starts at 0 at an index. This is technically the 0th character. This is the first character. This is the second character. If I were to try and grab everything from 0 to 0th, 1st, 2nd, 3rd, I think 4th maybe, I'd go 0 to 4, and then it would say hell, right? If I instead wanted to grab if I just wanted to grab the O, I'd probably go 5 to 6. No, I'd go 4 to 6. Then I grab the O and then the exclamation point. There is some nuance regarding the start position, and I believe the second one is inclusive. You also don't necessarily always need to have the second value here, so you can actually just feed it in a start, and then it'll just automatically run till the end of the string. That can be pretty useful because, you know, sometimes you don't know the length of the string, right? Sometimes you just want to grab everything from like the 3rd character onwards. If you think about it using our previous example, let's say I have something like this. Well, instead of using the extract domain, you could use slicing as an alternative to you extracting a domain if you wanted to. Obviously, the only issue would be if, you know, somebody removes the S and it's instead like an unvalidated or non-secure request, then all of a sudden we lose the first letter. So it's usually better in those cases to use the tools that were sort of meant for this, and then you'll be able to handle any flexible amount that you'd like. But yeah, slicing has a number of cool use cases, I would say. So I'm a fan. Generally a fan of the slice function. Let's go back to JSON.string and let's see what's next. We already covered split, so I'm just going to cover that. Next up, we have something called substring. Substring is, from my understanding, basically the exact same thing as slicing. I'm not really sure why there are two, to be completely honest. All this does is just returns the same thing that slice does. So let me give you an example. If we were to go 0 to 4, it's hell. If we were just replace this with slice, you see the result doesn't really change. So I'm not really sure why substring exists, to be completely honest. But yeah, this is just personally what I always use. I like slice better than substring because how much cooler does slice sound? We're slicing a string versus we're extracting a substring. You should just operate purely off of vibes, clearly. Anyway. Next up, we have a function that I use pretty often. It's called trim. Basically, what happens a lot of the time, especially when you're scraping resources, is you will get data, but that data will tend to have like a variable amount of white space to the left and to the right. White space just means a bunch of spaces or new lines or something. Trim just removes all of that for you. So, you know, I mean, they give you an example of lonely. Let me show you what this might actually look like with a string that we type in. You know, this is, hey, how's it going? Google.com, and then we have another space. What this does, as you can see here, there are 3 spaces. There's one at the beginning, there's one in the middle, and then there's one at the end. What this does is it just removes the ones on the end. Same thing, you know, if we added, well, I mean, you can't really do it, but if we added like a bunch of new line characters, tab characters as well, this isn't actually like taking any of those because the part of the way that this works is it just looks for the presence of that slash and then the NT, and I think there's one more. These characters just denote like a new line, which is pretty useful to use. So yeah, I like to use trim basically anytime that I'm feeding in a string that may have some sort of variable white space. When I'm scraping, I use trim all the time. And you know, just kind of make sure that my data is standardized, formatted well, and that I'm not just like asking for any additional, like I'm not using any additional characters or tokens. There's trim end and then there's trim start. This just does the same thing that I showed you guys earlier. It's just, it preferentially removes things at either the start or at the end. So trim end obviously just takes this out. If I were to change this to trim start, it would obviously just take that out. But I just tend to use trim more generally. We have two more functions under edit, and those are URL encode and then URL decode. Now, if you're unfamiliar with how this works, usually when you are dealing with a URL of some kind, you have characters that look kind of like this. You have percentage signs threes. I think those percentage sign 3D. I think those represent an equal sign. Percentage sign 20, that represents a space. The reason why you do this is because you can't actually just legally have, like if this is my URL, you can't actually legally have a bunch of spaces. So actually, let's go back and let's go docs.google.com. Like you can't say, hello, how are you? This would not be a valid URL, right? But what you could do is you go, number sign 20, number sign 20, number sign 20, and number sign 20. And now this would be like an actual URL. Now this is not a real URL, but it is like, it's not a URL somebody has created, but it is a real URL. Like we can actually press enter and format it. So all that this does is it basically converts something that may include those characters into something that doesn't, and vice versa. So let's hypothetically say you wanted to go to leftclick.ai, and then you wanted to go to, I don't know, blog post call, let's go blog. And then we go a post with the name of awesome. Okay. If we URL encoded this, what it would do is it would take all of the characters that aren't really like legally allowed. So, in our case, mostly these spaces, you see it actually also does some transformations under the hood to colons and backslashes and stuff like that, just because these characters aren't technically being rendered. It's just a way that, it's just kind of a quirk of how the browsers are rendering these to us. But in reality, when you like request to a server or something like that, they're being encoded. And then what you can do is you can then subsequently decode this, and then you can kind of transform it back to your initial URL. So sometimes you'll just see an API or something that'll say, this requires like URL encoded, or I don't know, this requires stuff encoded in a certain way. You can use URL encode when you're sending and receiving and making requests to things. I basically never really use this in practice, but it is something that they offer to you as a tool in case you need to. Okay, next up, we have a bunch of query functions. You've already covered ends with and includes. Now I'm going to cover index of. Index of is pretty cool. It basically allows you to find a substring that is present inside of the string and then tell you at what index did that substring occur. This can lead to some really interesting string manipulations and some cool use cases where like you'll find the index of something first, and then you will use that to take a slice or something from one character to another, and then do a bunch of other cool stuff, send and receive data that way. But yeah, I mean, in our hello example, right? If I were to feed in index of H, what do you think would happen? We'd feed in 0. E would be 1. L. And the thing about L is, notice that, I have 2 L characters there, right? So if I really wanted to get the index, I have to go LO, because that's a unique character there. I could also go O, which would be 4. I can go exclamation point, which would be 5. I go hell. I could go L. I could go LL. I could go low. And then I could go O exclamation point. And then I could get like basically a sliding window of 2 characters instead. But just notice how it always grabs the beginning of that. In their example, Steam and then T, we're finding the first index because S is at 0, T is at 1, and then even though it's 3 characters, TEA, it still starts at 1, which is pretty neat. So yeah, I use index of not super often, to be honest. I usually don't need to search through things numerically like that, but it's a good function to understand. Last index of is very similar to index of, but it solves that problem that we had a moment ago with the L. So, if we go index of, and we just type in an L, the result is 2. But if there are instances where we might have, some characters repeated multiple times or something, you can grab the last index of L and notice how that is now 3 in our hello string. Next, we have match. Match is pretty interesting, and you sort of need to understand a term called regular expressions in order to really get it. But essentially, this is a much more powerful find and replace sort of tool. I don't know if this function in particular allows you to replace something. I don't believe so. But it does allow you to find the thing, and then you could always just like grab that thing and then replace it later. But basically, let's say we have a string, right? And instead of hello, I'm going to use a much more varied example. I'm going to say, hey man, how are you doing today? Okay. And hypothetically, let's say we want to find the man, or we want to extract the man string. So if man is present inside of this, we want to extract it. If it's not, then we don't want to. Okay. What we do in order to do this is we build up something in what's called the regular expression, I think like templating language. So instead of just like identifying the thing, we're actually going to extract it. And the regular expression templating language, like it looks kind of weird. As you can see here, there's some backslashes and then there's some up arrows and stuff like that. It's not super difficult to do. If I were to just type in a \r, and then if I were to type in man and then another slash, sorry, if I were to type in a backslash and then man and then another backslash, and I really got to stop using the term backslash here. You can see that it did in fact extract man. But hypothetically, I could also, instead of just looking for man and like hard coding it like this, because this really doesn't do anything for us, right? Instead, what I can do is I could look for all instances of 3-letter words, okay? So in this language, it would be A to Z, A to Z. Then it would be A to Z, A to Z. When I just copy that one last time. And then we do that one more time. Now, in our case, we're matching the first instance of this. But if we wanted to match all, I think we'd feed in a G operator, which would be this backslash and this slash and then this G at the end, just because regular expressions are sort of outside of the scope of a video like this. And because it's an entirely new language, my go-to is if you want to build a regular expression, if you need one, and there are many, many instances in which you will need one, head over to this website over here, regex 101. You can insert whatever your string is that you want. Hey, how are you doing today? And then, you'd actually insert the test string down here. And then you actually have the ability to play around live and see how your changes extract various parts of the text. So as you can see, we have this backslash at the very beginning. The slash at the very beginning. We have the slash at the end. And then we have some options here. These options always just occur after the last slash. So in our case, global and multi-line. Again, this resource will explain everything to you if you look at it. But if you wanted to extract the man, you might type man. It's going to say that it's not matching the subject string because we don't have man in it. But if we say how, right, you'll see that as I type H, it illuminates 2 elements that are being extracted, HO. Now it's these and then HOW. There are also a bunch of really cool things. Maybe we want to go like you doing, right? But maybe instead of you doing, we just want to find the presence of you, and then we want to extract everything from you all the way to the end. Well, if I were to do that, then I could just go period, which matches any character, and then I could multiply it an infinite number of times to go to the end. Or maybe I want to grab everything before the U. So I'd go period U, and now I extract everything here. You can also play around with the presence of these 2 brackets. This allows you to extract specific sub-elements or sub-strings from the parent string. So as you can see here, now we have a green section that is illuminated because we've wrapped this in a capture group. And then the blue U section is sort of also captured, but it's not in our captured group. And yeah, that's just more or less a quick little rundown of what you can expect if you were to go super deep in regular expressions. I should also note that AI is really, really good at coming up with regular expressions for you. Like if I were to feed in this, and then I were to say, I want a regular expression to capture all 3-letter words in the above string. I were to press enter, and I'm just using a new model called O3 Mini High. It's new as of the time of this recording. Probably not going to be new by the time that you guys watch it. But if I were to do this, I would get something like this. And notice that it's always going to start with a slash, so I was going to end with a slash. And if I were to feed this in, if I were to remove the beginning and at the end, what you can see is we've basically gone through, we've extracted all 3-letter characters, and 3-letter words, and it's done a really good job of it. So over the course of the last, I want to say 6 months or so, AI has gotten to the point where you can do this as of the time of this recording. And if, you're wondering how exactly to do regular expressions and you're watching my video and you're like, what the hell is that guy doing? AI can do an even better job than I can, like 90% of the time already. So they're automating my regular expressions. What a dang shame. Next, we have another module or another function that uses regular expressions, but instead of returning the actual extraction, what we're doing is we're returning the place that the character occurred. So in this case, we're searching for N, and then we're going, I don't know, I think this is like at the beginning of a word and then anything else after that. And so it tells us, hey, what time does the first word start, or in what position does the first word starting with N occur? In this case, it's 0, 1, 2, 3, 4, and then 5. And keep in mind that regular expressions tend to be case sensitive unless I think you specifically turn that off. So it's not capturing the first capital N, it's capturing the second. I don't really use search basically ever, to be completely honest. Search to me just doesn't really have any value that index of doesn't. So From here on out, we are now moving into the validate section. So now we have a suite of functions that I use very often to validate whether something is a domain, whether something is an email, whether something is empty, whether something is not empty, whether something is numeric, or whether something is a URL. Let's start with domain. So remember earlier how we fed in HTTPS //leftclick.ai, right? And then I said that this was a URL. And inside of the URL, you had a protocol, you had some sort of delimiter, and then you had the domain name. Well, this will tell you whether or not what you're feeding in is a domain name. So what do you think? If I feed this in, is this a domain? The answer is no, because we've included the protocol and the delimiter as well. If I take this out, is domain now reversed to true? Now, alternatively, if I change this to is URL, you'll see that this is true. But if I just feed in a domain name, you'll see that this is false, because a URL requires all of the other subsequent components. Okay, we have a couple of other ones that we can go into as well. We can do empty. So if a string is empty, you can very quickly validate and check it. So obviously, is this empty? No, right? But if I were to take this and delete everything, then yes, it is empty. We can go is not empty, which is just the inverse of is empty. So is this not empty? Yes, true, this is not empty. There is a bunch of stuff inside. If I take it out, is this not empty? No, it is empty because there's nothing inside. And then similarly, in the same vein, we can do a little bit of checking to see whether or not something is an email. So if nick@leftclick.ai, you'll see that this converts to true because there is currently no top level domain. That's just the thing at the very end here. That isn't at least 2 characters, right? But if I were to just feed in a domain name, that would obviously be false. Quick and easy way to do validation and verification. And then there's also one for a numeric, which is somewhat interesting. Basically, what you have is the ability to check whether or not all that you fed in is a number. So you can feed in integers, you could feed in like decimals, you could feed in like negative numbers and stuff like that. And if it's a number, it'll tell you. If you feed in an F or an E or whatever, then, obviously this is no longer just a number. It's also a bunch of other characters here, which is why isNumeric is now reverting as false. Okay, the next functions are very simple and very straightforward. There are a bunch of case functions. So there's 2 lowercase, 2 sentence case, 2 snake case, 2 title case, and 2 uppercase. Lowercase is hopefully self-explanatory. Hello, how are you doing, Nick? If I feed in this, which has 2 capitalizations, it just lowercases everything. This might be useful when, I don't know, you're trying to convert something into a domain. So if I were to go, convert something like into a blog post slug. So let's say I had a blog post title and it's 38 ways to make money online, right? And I wanted to convert this into something that I could stick onto my URL, basically. What I could do first is I could replace all instances of a space, and I could do so with a dash. And then I could just go lowercase. And what I'm doing now is I'm converting this over to something that might actually fit inside of my URL. Pretty cool, right? That's what lowercase does. Now, obviously, there is an alternative, and that is, if I just remove this here, there are a bunch of other similar functions that change the case of the string that you're feeding in. So if I were to say 38 ways to make money online, and then I were to go uppercase, well, then we would just scream 38 ways to make money online. But there are a couple of other cases as well. There's something called sentence case. The way that sentence case works, if you're unfamiliar, is it basically just capitalizes the first letter of the entire string. So ways to make money online, right? If I were to remove this to sentence case, you'll see that I'm basically taking all of these and then I'm pumping them. I'd have to remove this dot as well. And then I'm bringing up all of the subsequent first letters of every word back up to capital case. If I put this in, I just remove that. And then there's a couple more. There's one called snake case. Snake case is pretty interesting. This basically does almost like what I was saying earlier with the URL replacement, but instead of a dash, we're doing an underscore. This is just like a way to create variable names really quickly because there are 2 naming conventions for variables. There's camel case and then there's snake case. Snake case just always has underscores between every word because spaces are not represented well in programming because parsers break. And then the last one is to title case. And what you'll see is nothing changes between this and this. The reason why is because this is already in title case. All title cases is it grabs the first letter of all major words. So I think words that are not connectors like to or at or a or the, and it makes them capital. So ways, make, money, man. If I were to go at, I guess that is. Oh, no, it's not. If I were to go then at would not be a connector. The, right? Most would, but not the. So yeah, I mean, all of these are just different ways to turn something into something else, which is nice. Okay, the next function is called parse JSON. It's pretty interesting, but basically the way that it works is a lot of the time when you receive queries from the internet, like when you do some sort of scraping or when you consult an API, what you get is you get something that has a lot of those escaped delimiters that I mentioned, those slashes before certain characters. So I'll give you guys a quick example and you'll understand this intuitively. Let's say I have a string here, okay? And this string is like a JSON object. So I'm going to go name, and in order to do this, I'm going to cancel it out, and then I'll go, Peter, like this, and then I'll wrap it. If I feed this into parse JSON, you'll see what happens is I'm actually parsing this out into an object. Like previously, this is a string, right? The string is this curly brace, the quote sign, name, other quote sign, colon, quote sign, Peter, and then quote sign, and then this other curly brace. But if I go parse JSON, what I'm actually doing is I'm converting this to an object. I'm literally converting the data type into another data type, which I will be showing you, cool things about. And if you parse this, if you click test step, what you'll see is, what I mean to say is, now that it's parsed, what you can do is you can actually reference things inside of the variable of the thing that you just parsed. So now, for example, I can actually just extract the name from this. So, I mean, obviously I'm just writing this all out right now, which is why this doesn't seem very useful. But you can imagine how if you receive a big, long string, well, you can actually parse it directly in your expression editor, which makes this super powerful. As I mentioned, I don't use this super often, just because I'm not like calling a lot of dedicated or hidden APIs where I find that this typically comes up. But you can use this so that you don't have to like add another node. You don't have to like render something or parse something in this node and then deal with it later. What you can do is actually just like get a string that contains JavaScript, parse it out, and then you'll be able to extract whatever value you want. So, because this is an object, I can now reference keys, or I can get values, right? I can do a lot of other stuff with it. And I'm going to be running you guys through the object functions in a moment. Okay, the next function is toBoolean. Boolean's pretty simple. Basically, if I feed in a 1 or a 0, what I do is I convert this data type from a string into this Boolean, which is true or false. So zeros are false, right? 0 is no, it's off, it's false in Boolean logic. 1 is on, it's true, it's good, right? So I'm basically converting this from a string into like a separate data type called true. I rarely use this in practice because most of the nodes in N8N that I'm realistically going to care about, they're going to have some sort of type conversion built in. This next one is called toDatetime. This is actually super useful because a lot of the time you're going to be converting to and from some standardized datetime format in order to do things like add a certain number of minutes, add a certain number of hours. The context here is N8N uses this specific type of datetime formatting called Lexan datetime. But basically all this does is it just allows you to convert like a string into another type of object that you can now do math with, basically, which is pretty cool. So I'll give you guys a quick example just to show you guys just how many things are representable as dates. If you just feed in like the number 1, it will find the first date of 2001. Why? I don't know. There's just some logic that's going on under the hood. But hypothetically, if I were to grab the current date in, I think like month, day, year format, it would be 01/31/2024, right? So now this is converting the current date to this standardized date format. Sorry, I guess 2025. It converts into the standardized datetime format. What's the cool thing about this? Well, if I press dot here now, what I can do is now I have a whole other function suite available to me that includes datetime specific functions. So now we can do a bunch of really cool things. We could convert to locale string. And now this actually converts this into the specific, basically they grab my locale and then it converts it into the specific type of string that people are most likely to see here. So you can imagine this might be really, really useful if you're working in databases or something like that. There are a variety of other datetime functions as well, which we're going to get into, but yeah, you can do things like extract certain times. You can do things like subtract, 5 days from January the 31st to give us January the 26th. All this stuff ends up being super, super valuable when you're working. Okay, great. The last thing I want to cover is toNumber. So let's say I have the number 123,504, okay? All this does is it takes the string that is 123,504 and converts it to a number. What do I mean by this? Well, numbers and strings are different. right? And so all this is doing is it's allowing me to do a conversion from the string format of 120,504 to the number format 123,504, which means now I can do things like I can add. So I just added 5, right? If I were to try adding 5 to the string, all we do is we actually literally add the string 5 to it. You guys kind of see what I mean? If I go 123,504 plus 5, what I'm doing is I'm appending 5 to this 4. I'm concatenating. But if I make this into a number, well, now we can actually perform a logic on it. We can I don't know, multiply it by 5 or 12, right? If you were to not, then, if you were to try and multiply a string by 12, I guess it would allow you to, because this is like a very clear operator. But yeah, the plus specifically is sort of like the breaking example of doing mathematical operations on strings. And this is equivalent to concat 12, as we could see here. So basically all this is doing is it's just verifying that this thing is a number. And then once it's a number, we can do a ton of like really cool, math and stuff like that with it. I use toNumber reasonably often. Yeah, a lot of the time, I'll grab a string. That string is formatted in like a particular way, and then I extract it. I turn it into a number, and then once I've turned it into a number, I can do really cool things with it. And then there's one other example here in N8N where you can have a number that's like 1.23e10. That's like 1.23 raised to the 10. Well, you can actually take the string and then you can convert it into like a usable number that you can perform mathematical operations on. This is sort of like more of a scientific need, so you're not going to use it super often. But I do use toNumber just to make sure that my types are okay. Okay, next up we have the number family of functions. This is pretty straightforward now that we've done string. I'll say that string and array are probably the most difficult ones. This one's going to be a little bit easier. Let's just type in the number, and now let's reveal all the functions available to us. So the first one we're going to cover is round. Round is kind of what it sounds like. If I were to feed in JSON.number, which in our case is 3.5, into round, what happens? This goes up to 4. If I were to try and change the number of decimal places and go 2, it'll round it to 3.5. If I go 3, it won't do anything because this number doesn't have any more decimal points, right? But yeah, this will automatically round up to 4, which is just default behavior. Anything up to 3.4999 repeater will round down. Anything at 3.5 and up will round up. And yeah, this is just sort of like default behavior. It's great for like removing complexity from numbers and stuff like that. Now, I should note, I want to show you guys a little bit more context here. I don't just want to use JSON number. So if you want to write a number in N8N, you could do so just by wrapping round brackets around it like this. So if I'm rounding 234.5, this will be 235, right? If I'm going 4999, it'll be down. But what if I go this, and then I went around to the second decimal point? How about the third decimal point? The fourth decimal point? I don't think they're, yes, sorry, I was just getting a lag actually. But when I round to the sixth decimal point, all the way over here, right? If this is a 3, it would be down. If it's a 6, it would be up, right? Because we have a 5 down here. Anyway, the point I'm making is you can round stuff, and rounding is cool. All right, now why don't we do the more directed version of round, which is where we specifically say, am I aiming for the floor or am I aiming for the ceiling? So if I aim for the floor of 3.5, what do you guys think is going to happen? This is going to return me the number 3. If I aim for the ceil of 3.5, what's going to happen? This is going to return me the number 4. So basically, this is just a directed way to perform your rounding operation sort of manually, right? 3.8 is always going to go up to 4. 3.1 is going to go up to 4. If I were to replace this now with the number 3, the ceiling of 3 would be 3. 2.9 would be 3. 2.1 would be 3. 2 would be 2. 2.0001 would be 3. So it's interesting, just how much granularity N8N gives you in being able to manipulate numbers with this. But yeah, that's the way that ceil works. The next number function is called abs. That stands for absolute, not my ripped 6-pack. Basically, when you feed in something like a number here, you can do so, with positives or with negatives or whatever. All this does is just returns to you what's called the absolute value of that number. So abs just says, hey, if there's any negatives or something like that, I just want you to get the absolute magnitude of it. If I feed in negative 2.0001, it'll just return me 2. So you can kind of think of it as just a way to strip negatives, get only the actual magnitude of the thing, magnitude being the distance from 0. Okay, on top of that, we also have a few other interesting ones like format. Now, the way that format works is basically, you know how sometimes Americans and Europeans will format numbers differently. Like sometimes Europeans might put like the euro at the end of the sign or something, end of the number, and then Americans sometimes might put the $sign or usually at the beginning of the number. Sometimes they use periods as delimiters and 1,000 separators instead of commas and stuff. Format just deals with all of that. Now I'm feeding in 3.5 and I'm trying to format it. That doesn't really make much sense for me. So let me just feed in a bigger number and show you guys how it works intuitively. Let's say I fed in 3,459,221. If I were to leave this up to the standard way that the format module or format function, I should say, formats things, I'm basically converting this and then I'm adding a bunch of these little delimiters. But I could also change this. If I just add a period instead, oh, sorry, if I, my bad, you didn't actually add the delimiter. If I had the locale string instead, right? If instead I wanted to go French, you'll see that we've now added a space in between instead of the comma. If I wanted to go Dutch instead, I think Dutch, I may be mistaken, but if I wanted to go Dutch instead, we now add periods, right? This can be useful when, I don't know, you want to drop like a $sign in front or something like that, right? If I go EN here, then now we have basically like a number that maybe we've done some math on to get to this point. And now we've turned this into something that is like realistically readable as, I don't know, a string, which we could do tons of things with. We could pass it into a pandadoc proposal and template out, the amount of money it costs, make things look a little bit prettier, essentially. So that's pretty neat. I'm a fan of format. I use format pretty often. Aside from that, we have a couple of very simple functions. Is even just tells you whether or not this number is even. So is this number even? No, because there's a 1 at the end, but if it's a 0, then it'll be true. Likewise, there's is odd. So is this number even? No. Is this number odd? Yes. Is this number odd? No. There are a few other ones like is integer. And if you guys are unfamiliar, an integer just sort of means like a number that doesn't have any decimal points. So this is an integer because there's no decimal points. But if I were to do this, then this would no longer be an integer. This can be important sometimes, but to be honest, I don't really use these type conversions or is even or is odd very often. There are certainly places for them though. Next up, we have some conversion functions. So to Boolean, similarly to what we had before. To Boolean will convert this to true. Like if I go 0, this will be false. If I go 1, it's true. Then if I go any number above 1, it's also true. So basically 0 is just the only negative. And then even like negative numbers and stuff like that are technically true as numbers. This is some nuance that isn't super important to understand, but yeah, just to say that you can convert this into the true or the false Boolean type. There are also ways to convert numbers to date times. So 43, is extracted as this. If I wanted to convert this number to a date time, I would go and I'd get a timestamp. Unix timestamp is the number of seconds since January the 1st, 1970. So I'm just going to copy this. I'm going to go over here. I'm going to feed this in. What this does is it tells me what the current date time is. I think I have to add 3 zeros actually when I do that, because I think this one does it with thousands. But anyway, as we can see, the date time here is now 2025-01-31. It is 3:06:41 according to my time zone, which is nice. I think they automatically do -07 because that's where I'm at. But yeah, you can convert a number of things from numbers or numeric, like numbers into dates as well to perform functions on later. And I should note that, this is a number, like this right over here is a number. So what you could theoretically do is you could probably do this. So you know how earlier I had to add that 1,000 separator. If you just multiply this by 1,000 first instead, then this is still technically like a functioning number, right? Because basically what I'm doing is I'm taking this number, I'm defining it, then I'm multiplying it by 1,000, then I'm converting that to a date time, which is now rendered correctly. This will sort of muck up the date time, but 1,000s. In my case, it's just the N8N conversion between a Unix epoch timestamp over here, and then, what N8N is comfortable with. Okay, great. We have a couple of additional ones. The only ones that are really important are the locale string. So this converts things from, I don't know, let's say 500 and then 50,304. Sorry, 50,050,304 automatically converts this into a string with those commas and everything like that in them. There are a variety of things that you can do. You could use the same settings that we had before. So remember how earlier, if I go to the C full list, Remember how earlier, I fed in FR. Well, there's also a variety of other ways that things can be formatted. And this is just like a master list of all of them. And some of them will be, well, most of them are going to be very similar to each other, but some of them are also going to be a little bit different. And this just allows you to format things into the particular locale, or it allows you to format it into a string that is of the particular locale of the people that you want. And sort of like an automatic basis, which is pretty nice. And then the last one is obviously just toString. ToString just converts a number, which you perform functions on, perform mathematical operations on, into a string that you can now do things like concatenate with the term hello, right? So you couldn't just add the term hello to 50,050,304 because that doesn't really make sense. But since we converted to a string first, this is now basically this. And then we can easily concatenate any string to this if we want. All right, that is the number family. Let's move over to the array family, and let's knock these out. What I have over here on the left-hand side is I have an array with 3 items, Sarah, Sally, and Stephanie. This is clearly an array of names. You can also create your own array in N8N, similarly to how we've been doing so far, just by using the square bracket operator. All right, this is technically now rendered as an array in code that we could do things with just by dot notating. But in our case, as usual, I'm going to start off with that just to show you guys how all of this works. And we can see our array has now been pulled and rendered as a variable from the previous node. So if I click period, what sort of functions are available to me? Well, the first is length, which is probably pretty similar to the string one. It's just instead of counting the number of characters, what we do is we count the number of elements in the array. So we had Sarah, Sally, and Stephanie. Those are 3 elements. It's not surprising then that we have a length that equates to 3. Now we have some other functions here. Last. If I were to put this in, what do you think would happen? Well, we'd extract the last element, Stephanie. Likewise, if I were to extract the first element, Sarah. We can do includes. This one in practice I use very often, and this just verifies whether or not there is the element that I'm looking for in this array. So sometimes APIs will return big arrays with tons of elements, and all I'm curious about is, hey, does this contain the thing that I want? Well, does this contain Sally? Yes. Does this contain Saul? No. But does this contain Sally? Yes. Remember, we're now doing this on a array basis. So we're looking for the array elements that need to match these strings exactly, as opposed to just the string basis. If we did a string, and then we typed a substring or a slice of that, it would have returned as true, right? But now that we're operating off of arrays, we need to make sure that they match one-to-one. Okay, we have map and we have filter, and these are a little bit more complicated, so I'm going to leave them till the end. But moving our way down, the next function is append. Now, append is just a way that you can add an additional element to an array. If you append something, you're sticking it on the end. So if I were to add the guy's name here, let's go Eric. Then if we append, quote, Eric, quote, we've now added something to the end of that array. So I use this pretty often. The interesting part here that people don't know most of the time is that you can actually just feed in another array. So maybe we have like a guy's array over here. You can append a number of things. In my case, I've just appended another array inside of that array. You can also append other data types like numbers. So keep in mind, Sally, Sarah, and Stephanie, they all have quotes around them. You can also append things like objects. So I believe in order to do this, we actually need to go like this. No, my bad. There are so many quote signs here. I don't know what the hell's going on. So in order to append this puppy, we'll remove that. And then we could see that the next element over here is an object, right? It's an object with name equals Peter. So yeah, you can append a variety of things to an array, but append is just a way to add to the end of it. Another function I'll show off is chunk. Chunk is pretty cool. Basically, if we have an array and the array has, I don't know, in this case, it has 3 elements, so this isn't really going to work. But basically, let's say it has like, I don't know, 10 elements or something like that. We can chunk it into subarrays of 2. So let me make one really quickly. Okay, and if I just copy this, and then if I feed this in over here, basically what we can do is we can chunk this into a bunch of subarrays that contain the number of elements that we specify in our chunk. So laptop, backpack, smartphone, notebook, pen, headphones, water bottle, whatever. We're now chunking this into an array where we have 2 items. So I don't know, maybe in this specific case, we're asking people to bring, everybody brings 2 items or something, and then like we all get them together. That way, I don't know, we're sort of at like the same level carrying wise. Nobody's carrying a bunch of stuff. If you wanted to chunk this more, maybe you'd go 3, you go 5, If you want to do 1, that's just obviously sort of silly because you're just nesting every element inside of another element. 0 breaks, so don't do that. But yeah, that's kind of how chunk works. Do I use chunk? Basically never. But I figured I'd at least mention what chunk was. Okay, we'll go down to chunk. Sorry, we'll go down to JSON.array, and then working our way down here, we also have a very interesting function called compact. Hypothetically, let's say we had that array that we had earlier, but let's also say that, I don't know, a bunch of these elements were empty. So if we look at what's being returned here, you see we're being returned an array that still has, 10 elements, but 3 of them are empty. Well, hypothetically, what you can do is if you just wanted to only get the elements in the array that had values, you just type in .compact, and it would actually strip everything that is empty. I should note that these quotes aren't the only things that you can have. You can also have null. This null is not wrapped in quotes, and it's a special series of characters that's just like understood by JavaScript to mean that there's like a null entry there. But yeah, compact is just a quick and easy way to get rid of these null entries or empty entries. And this can be valuable because sometimes this is how APIs send information back and forth, right? You'll receive some big long array and then like 50 of the fields inside will be empty. Well, this way allows you to just strip those and then only operate off of the data that actually matters to you. Okay, the next function is concat. So as you can imagine, this is very similar to sort of append insofar that you can add a bunch of things to it. In this case, if I wanted to add Sarah or something. We've now added an additional element inside called Sarah, but I could also add, like I did before, an array with Peter and then, I don't know, Eric. And now what I've done is I haven't added a sub-array, so it's not like I've added an additional array inside like I did with append. And what I'm actually doing is I'm just like taking these 2 arrays and I'm just sticking them together. So you can kind of think of it as like squishing 2 arrays together without really preserving like the data type necessarily. Next up, we have a very interesting function, one that I use quite often called difference. I'll also show you its intersection, which is, I'll show you its inverse, which is called intersection. But I'm just going to create a new array and I'll go 1, 2, 3. And then I'm going to go difference. Then I'll go 3, 4, 4, 5. So basically, I need to make this an array. So basically, what difference does is difference just returns you all of the elements from the first array that are not in the second array, okay? So 1 and 2 are not in the second array. 3 is in the second array, so we're only getting 1 and 2. Difference doesn't care about all of the elements here, like you don't insert any of these elements here. It only ever uses the first array that you feed in as like the primary data. So if I were to say 2, what do you think would happen? Well, if I click 2, obviously, this is now going to disappear because one of the elements here is now over here, and the only element that is unique, you kind of think of this as like a unique element, although there's another function called unique, so it might not be good to conceptualize that way. But all of this does is this just takes all of the elements here that are not in this array. So there are tons of ways and reasons why you should use this. One way that I just used this the other day is I'm tracking a bunch of other people on YouTube that are about the similar size to me, just because I want to see if there's differences in posting schedule, lengths of the videos, or something like that. And so I'm calling a YouTube RSS feed. The YouTube RSS feed brings me an array of a bunch of YouTube posts that they make. Well, I can store their YouTube posts in a database, and then all I can do is I can just compare to see, hey, is this RSS feed array different from this RSS feed array? Oh, it is? Okay, well, what's the difference? Is it that post? Okay, great. Well, now I know that that's the post that I'm going to take to like update my database with. I'm going to add that post essentially. So yeah, variety of ways you could do this. If we use our example here of, names, maybe what I'm doing is I'm just looking for any name from this array that is not in this array back here. So Stephanie, for instance, is not in Sarah, Sally, or Peter, hence why I'm returning Stephanie. Now, the inverse of this is called intersection. And this is similarly another function that I use all the time. And intersection is super valuable. Basically, instead of looking for the difference, it looks for the instances in which we have both data. So we have Sarah in both arrays, so that's what I'm going to return. We have Sally in both arrays. That's what I'm going to return. Do we have Stephanie in both arrays? No, we have another name called Peter, right? So intersection and difference are both fantastic. And they're things that, if you're working with any sort of like real industrial or enterprise data, I think you're going to find yourself using all the time. Okay, the next function I want to cover is called find. Find is pretty sweet. Basically, it allows you to use math as part of your function. So if you just press enter, you'll see that we've now added, it doesn't just allow you to use math, sorry, it allows you to use like any sort of operator. Now we've added this cool little syntax, which is called like arrow notation or arrow syntax in JavaScript, where we've got .find, and now we have an element. So we now have some variable that we're calling item, and we're saying true. This is pretty interesting. The way that this works is, think of item as the individual item in the array. So all we're doing is we're basically saying, hey, array 0 is equal to item. So item is just the name that we're going to use to reference the specific item in the array that we are currently at, because it's going to go through all of the items. So this is kind of a piss poor example. I don't really know why they do that, but let me show you something that you can do with this. What if we want to return all of the elements in an array that are greater than, let's see, I don't know, they're greater, they have more characters than 6. So Sarah has 5 characters, Sally has 5 characters, but Stephanie has way more than 6, realistically. I think it has like 10 or something like that. So maybe, I don't know, we're just looking to see if there are any names in our array that are longer than a certain number of characters. How would you do this? Well, it's actually really easy. We go $JSON.array.find, and then we take the thing, item, and then we just check to see if item length is over 6. And if so, then our result is Stephanie. We're finding an element in an array that corresponds to this, okay? Now, there's some nuance and some things here that I should explain. There's another function that does something very similar to this called called filter, which I'll cover in a second. But this element is special because it only returns the first instance of the element that satisfies the request. So JSON.array.find, we define our item, and we're saying the constraint is the item.length needs to be less than 6, is going to return Sarah, but it's not going to return Sally, even though Sally also fulfills that request technically. So find is super powerful. I don't use find as much as I use map and filter, but I'm going to cover all of them regardless. The very important thing to know here is you just need to be comfortable using array syntax, arrow syntax. This is called an arrow function in JavaScript. So I should note that it doesn't need to say item. It could say I. As long as the element or the way that you've named it on the left is the same as the way you've named it on the right, this satisfies the condition. So in our case, I is just a symbol that we're using to denote all of the different elements in the array, one by one. Okay, great. So that's find. Find is pretty awesome. Let's now cover index of. Index of, as I'm sure you can imagine, is very similar in the array format to the way that things are represented in the string format. If we are looking to find the index of the entry called Sally, well, then the entry is 1. This is 0, this is 1, this is 2. What if we wanted to find Sarah? It'll return 0. What if we wanted to find Stephanie? This will return 2, right? So that's what index of does. And one common theme that you'll find is that arrays and strings are actually pretty similar in terms of what's going on under the hood mathematically. Next up, we have isEmpty. If I feed in this array with 3 elements to isEmpty, obviously it's going to return false. We also have isNotEmpty, which is the inverse. And then we have a very special function, one that I use very often, called join. And all join is it's the inverse of split. Remember how earlier we took a string and then we split it into an array? Well, join just takes an array and then it takes an array and then it turns it into a string. So in our case, we have Sarah, Sally, and Stephanie here. We can actually just join all those together and then we can get Sarah, Sally, Stephanie. This is now a string. So hypothetically, what if I wanted instead to put plus signs between them? Sarah plus Sally plus Stephanie. Well, all I do is I go space, plus, and then space. So what join does is it just gets all the elements as they're laid out, and then it adds whatever characters you want between all of them. So we go comma space, we could go this, we go underscore, right? We have a ton of options here. We have a ton of options here for how we want to do the separator, which is pretty cool. So I use this all the time. I mean, this is how I turn a bunch of array data into like a string or something, right? I also use this to convert things into like CSV format, which is where you have like a comma between. And then the cool thing is you can just take the CSV, you can actually make a file of it and just upload it to a Google Drive or something. So tons of examples here. You know, they show you how to do 3 with a space plus space. If you just join with nothing, then if you join with like an empty string, it'll just kind of stack them all together. This is very similar to like a text aggregator sort of function if you're using make or some sort of aggregation function in most no-code platforms. Okay, great. Let's now cover merge. Now, all merge does is it allows you to take a specific type of array And that's the type of array that has objects as elements instead of just numbers, strings, or Booleans, or subarrays. It allows you to basically take them all and then stick them into one big object. So if you think about this, what we're really doing is we're converting from an array into an object. I'll give you guys a quick example of what that looks like by actually creating my own. If I were to grab my own array, and then I were to create an object inside of said array where I have name Nick, that's object number 1, and then I were to say city, the automatic quote adding is kind of annoying. So the automatic curly brace adding is kind of annoying. Okay, so name Nick. Let's do city Calgary. And then we'll go, I don't know, height, and then we'll go like 188 or something. Just like this. Right, we now have an array that contains 3 elements. We have name Nick, we have city Calgary, and then we have height 188. What if we just wanted to convert this into one object? Well, we just go merge. Sorry, that's not going to work because we're outside of these curly brackets. We just add a space here to make our lives easier. We go dot merge now. And now we've basically taken an array and we've converted it into an object where all of the array elements are now just key names in one. So it's name, Nick, city, Calgary, height, 188. This is now just one object. And now, instead of a bunch of array functions, we actually have a bunch of object functions available to us, which I'm going to go over later. So merge is, I mean, like I understand why they put merge in, but do I ever actually use it in practice? No, not really. Next up, we have pluck. Pluck is pretty badass. Basically, what we get to do is if I were to feed in the same thing that I just fed in before, then instead of merging it, I were to pluck it. What I can do is I can extract the specific things from this array of objects. Like if I had name and then, this isn't a very good example, but if I were to pluck out the name, what I'd get as a result is I'd get Nick. Okay. Pluck just allows you to extract the value of something that has a key name equal to what you've put in here. So hypothetically, if I were to just have another person in with the name Sally, what I've done is I've plucked out all of the names. I've plucked out Nick, I've plucked out Sally. This is another one of those manipulation functions, which I don't really use too often, but it's not bad to know. The next function we have is called random item. It is fantastic. Random item is just a quick way to select something from an array. I use this all the time. I use this in like round robin scheduling. Well, not round robin scheduling, sorry, like random scheduling. I use this when like I'll generate a list of random numbers and I'll just select one. Although to be fair, there is like a random function that you can use. I use these to like, statistically, randomly and uniformly just take things from an array and then do things with it. The next function is called rename keys. You guys remember that example function I had earlier? If I just go back to it. If I had a bunch of entries with name, and then name, and instead of using pluck, I were to use rename keys. What rename keys allows you to do is it basically allows you to add to search for a specific key name of the object, so in this case name, then convert it to something else. So maybe instead of name, what I want is I actually want to call it first name. Well, this will now create another array, but it'll automatically go in and it'll rename all of the keys and all of the objects in said array. This is another one of those like more complicated like data formatting functions that I don't really find myself using often, but I have used this before and it's worth at least knowing. Okay, and JSON.array reverse does probably what you're expecting it to do. It just takes as input an array. So in my case, an array of Sarah, Sally, and Stephanie, and then it reverses it. But for some weird reason, every time I put JSON.array.reverse in, it crashes my N8N server entirely, and then I have to spin it up again. So this is a very interesting development, if I'm honest. I wasn't expecting this one function to just consistently crash, but I've repeated the behavior a number of times and just does not really seem to be cooperating. Anyway, imagine if it said Sarah, Sally, and Stephanie in your input. The output would be Stephanie, Sally, and then Sarah. Sally is the middle unit, so it wouldn't necessarily change. Anyway, I'm going to exit this page, fix it, and then come back. Okay, next we have the slice function. The slice function works the exact same in an array as it does in a string. If we wanted to slice between 0 and 2, we get Sarah and Sally. If we want to go 1 and 3, we'd get Sally and Stephanie. Next up, we have a very interesting one called smart join. Basically, I'm going to rely off the given example here just because it's such a nuanced and I want to say uncommon function to use that I don't really use it basically ever. But over here, you see how we have an object that is specifically formatted as follows: field age value 2, field city value Berlin. Okay. Let me copy this over. I'll show you guys what this means. If I were to pump this in, and I were to go to smart join, and if I were to feed in field and then value, and I close it off, and what this would do is it would basically take as input my array, and my array is broken down into basically an object with a field and a value for every thing. Like if you think about it, there's no need to break it into a field and then an age and then a value and then a 2. You could just go age and then 2, right? City and then Berlin. But it takes this very particular formatting and then it basically plucks, similar like to what we were doing before, it plucks out the fields and then the values, and then it uses it to turn into a new object where the first element that you feed in is going to be the key, and then the second element that you feed in is going to be the value. I don't really ever use this, so I probably wouldn't worry too much about understanding it if you don't. Next up, we have sort. Sort just sorts things alphabetically to start. If you want to do anything more complex than alphabetical sorting, you're going to have to use one of those arrow functions that we talked about again. And unfortunately, the way that the arrow function works is not very intuitive. It's just a hand-me-down of I guess, like some programming or JavaScript conventions. Basically, you want to grab A, which is going to be your earlier element, and you want to grab B, which is your later element. You just always want to wrap it like this. And then in order to turn this A, bracket A, comma B into some sort of inverse order, what you'd have to do is you have to go to B, locale compare, and then go A like this. It's kind of annoying, but we've just reversed it basically. We've sorted this. Well, we didn't reverse it actually. We sorted this based off of the presence of the characters in the alphabet. SAL comes before SAR, which comes after ST. I think I mixed myself up there. SAL comes before SAR, which comes before ST. Because we're doing this inverse comparison. If you were to go alphabetically, it would just be standard. It'd just be A and then B. Why you have to use the locale compare thing in this particular format, to be honest, I don't really understand or get. I don't really ever sort anything other than numbers from like largest to greatest or strings alphabetically ascending. And then if you think about it, if you sort things one way, you can also just sort it and then you can just reverse it in order to get the other thing, right? So like most of the time in practice, I'll sort first and then I will reverse after. Now, I'm not going to type the 2 brackets there because I have a feeling it's probably going to break my N8N instance again for whatever reason. But yeah, that's how that works. Next up, we have JSON string. This just converts all of the elements in an array into like a JSON string that you could do stuff with. So this is now a string. It's not an object, it's a string, and you can do string manipulations on it. A lot of the time you have to convert things into JSON strings in order to send or receive them through APIs, so I'll use this reasonably often. Next, we have toSpliced. toSpliced is actually really, really interesting, and I could see a lot of cool uses for it, but I personally don't use it very often. Essentially what it allows you to do is allows you to take as input an array, and then what you do is you will add specific elements at an index that you specify, then remove a bunch of elements after that, and then actually designate the thing that you want to add. So I know that sounds kind of difficult, but let me show you as our example. Sally, Sarah, Stephanie. Let's say this is the 0th position. This is the 1st position. And this is the 2nd position, right? Let's say I want to add something at the 1st position right over here. So in order to add something, I go 1, and then I go comma 0, and I'll show you why in a moment. And then let's say I just wanted to add another S name. Let's say, oh geez, I already have Sally. Samantha? Yeah, Samantha. I would type in like this. What I've done is I've inserted Samantha into the 1st place of our array. If I wanted to move it so that it's after Sarah, I just go 2. If I want to do it so it's after Stephanie, I go 3. And I don't know, can I add it in 4th? No, I can't, because it takes the length of the string, length of the array, and then it sticks it in at the end. So yeah, this is me just bringing Samantha back, baby. That's what I'm doing. Now I'm bringing her forwards. I have the power. Next up is the second parameter is kind of interesting. Basically what this does is it deletes a certain number of entries, which is kind of neat. You can delete the number of entries from the start index onwards. If I want to delete, I don't know, let's say like 5, let's say 3 entries or something. I think I have to refresh this, unfortunately. Let's do 1. Sorry, let's do 1. Yeah, because we can't delete anything at the 3rd index because there's nothing left. But hypothetically, we go 0, 0 first. If I go, if I delete everything from the 0th index, and then I go 1 out, I'm going to delete between 0 and 1, which is this, right? If I go 2, I'll delete Sarah as well. If I go 3, I'll delete Stephanie. That still allows me to add Samantha, though. Sometimes the N8N editor will sort of bug out like this if you have an additional comma, so just be really careful. But anyway, this still allows me to add Samantha. So the way that I like to think about this function is just sort of like an all-in-one. If you wanted to do 2 or 3 things simultaneously, if you wanted to add an element at a specific place, then if you wanted to remove a bunch of elements, and then if you wanted to, I don't know, like designate a specific element to add, then you'd be able to do so here. The cool thing is this can be an array, so I could add more people here too. So I could add like Samantha, Peter, and then Stacy. And then I could use that to, if you think about it logically, replace the 3 elements that I have in here. So like, this is what the string looks like when I concatenate them. This is them afterwards. So this is just sort of like I don't know, it's like a 3-in-1, if that makes sense. Do I use this one often? No, I do not. Still pretty cool though. You could probably impress some people. The next one I want to cover is called union. Union is pretty awesome. This is it's the union operator in logic. And basically, if you feed in 2 arrays and they have overlapping elements, it will just ignore the overlapping elements and then just give you a unique total array, which only contains unique elements. So you know how we have Sarah, Sally, and Stephanie? Let's say I feed in another one with Sarah, Sally, and then Stacy. What we do is we basically add these 2. We perform a union on the first, which was Sarah, Sally, and then Stephanie, and then the second, which is Sarah, Sally, and Stacy. And we don't duplicate the Sarah and Sally elements, right? These are unique. We just add the single new element that's sort of like a difference between the 2. So you can kind of think of this as similar to the intersection and the difference functions. This one just doesn't preferentially add things from the beginning or the end. It just does it with both equally, which is nice. The next function is unique, and I use unique all the time. This just tells us, or rather it displays only the things that are unique in your array. So this is a very quick way to deduplicate data. If you think about an array, and I have 1, 2, 3, 4, 5, 5, and I pass it through the unique function, I'm only going to have 5 remaining. If I go 3, 4, 5, 2, 2, 3, you can see I've added nothing. But if I go 6, now I've added a single additional element. And it does so by preserving the placement as well, which is quite handy. So I use unique all the time. Very, very common for me to use unique. Okay, let's now cover the 2 functions that I've been leaving until the very end here. Actually, 3 functions, if we count reduce as well. Map, filter, and reduce. These are extraordinarily powerful. I use map and filter all the time specifically. And these, if you figure them out, will end up being probably your most used array functions because they are just the cardinal V array functions. So the first thing that I'm going to do is I'm going to do map. Now, if you remember back to that previous function that I showed you guys, we are now going to be using arrow syntax again, where we have some item. And then what we're doing, all the map does is map just does something to the item. Okay. So let's hypothetically say I wanted to append gmail.com to all of these entries. I could do so very simply just by concatenating gmail.com. Let's do @gmail.com like that. So what I've done is I've taken my item, which is I, and then I've said for every item, I want you to perform this function, I.concat and then gmail.com. Pretty sweet, right? Well, why don't we now make them all lowercase as well? 2 lowercase, then I double up on the brackets. Now you can see that we have basically all of these formatted as email addresses. So now I'm kind of mixing and matching, combining functions, which is cool. Okay, so what's really cool about the map is, I just did this with a string, right? But you can do this with whatever data type. Like hypothetically, if instead of JSON array, I fed in 1, 2, 3 into map, what I could do is I could just multiply this by 2, then I can instantly change all of these a proportional amount. If I divide these, I could do a bunch of cool stuff with that as well. Modulo 2, probably. Like there's so much that you could do with the map function. It's crazy. I'm not even going to start, but just know that this solves like 99.9% of all array queries. Now, similarly to the map function, you also have one called the filter function. If you've never used the filter function before, I'm just going to give it a click because it'll automatically detect this out for me. What the filter function does is it basically does the same thing as map insofar that it goes over every element in your array, but it allows you to filter out elements that don't match the criteria. So let's say I have a simple array here, 1, 2, and 3, and I filter out all elements where I is less than 3, right? So all elements where I is less than 3, well, 1 is less than 3, 2 is less than 3, 3 logically is not less than 3, it is 3. So I only have 1 and 2. Okay, if I were to do this with my array I could also filter based off of string constraints. So my array, if you think about it, is Sarah, Sally, and Stephanie. What if I was only interested in returning entries that had a length of less than 6? Sally and Sarah. More than 6, Stephanie. So we're basically doing the same thing as find, but we're doing it a little bit differently. We're sort of proceeding with it a little bit differently. So map and filters, I mentioned, are fantastic. I use them all the time. There's one more which employs similar logic, but you're probably not going to end up using it anywhere near as much. It's called reduce. Now, reduce can be very complicated to understand. So I'm just going to cover it like really, really briefly. But essentially what it allows you to do is it allows you to define your own function, and then you can do stuff to things iteratively. So let's say I have 1, 2, 3, 4, 5, okay? I'm reducing. What you do is you have some accumulator, then you have some initial value, and then you have an arrow where you go accumulator plus initial value. So what's happening, I think it's called initial value. It might have some other term for it. I might be misunderstanding. But basically you have like A and then you have B. Then what you want to return is you want to return A plus B. So what this does is it says A is your current number. So whatever current element. So A would be, for the first pass around, be 1. And then B would be the one next to it. Okay? So 1 plus 2. Then it would take the result of 1 plus 2, which is 3, and then it would add it to the next thing, which would be 3 plus 3. Then it would take that result, which would be 6, and add it to the next thing, 6 plus 4. Take that result, which is 10, add it to the next thing, 10 plus 5. What do we get as a result? We get 15. Now, you can do a number of things that aren't just mathematical functions to this, but this is sort of like an accumulator, like it aggregates things the further it goes along. So obviously large arrays, that you're running some functions on, will be bigger and bigger and bigger mathematically. You can do things like divide too. So I don't know, A divided by B. It's kind of interesting. A times B obviously grows. A minus B, you're going to get a negative number, right? Because you're going backwards. But I'll leave reduce there just because, in practice, you're probably rarely going to use it. Okay, that now takes us to the object suite of functions. I'm just going to change the type to object here. And I'm now going to be extracting data from this, which is an object that is nested one level deep with a first name, a last name, and a height in centimeters. Apparently, Kvothe Arleden, one of my favorite characters from fantasy, is 186 centimeters. Wonderful. So I'm going to go JSON.object. Now I have access to this, and I'm going to press dot. And the first thing you're going to see when you're operating with an object is you're going to see some additional fields up at the top. So basically, we'll go in, we'll parse this out, and then we have access to the first name, the last name, and the height in centimeters. So these aren't functions, these are parameters, but I'm going to write them down anyway. First name will equate to Kvothe, right? Last name will equate to Arleden. And then height in cm will equate to 186. Pretty neat, huh? So these aren't functions, as I mentioned. These are just ways to reference, values in set array. Let's actually get into the functions. There aren't too many of them, so it's going to be pretty straightforward. The first is called keys. Keys is pretty self-explanatory. All we do is we just get the keys, and we pluck it out and turn it into an array. So in our object, first name, last name, and height in centimeters, these are all the keys. On the right-hand side, Kvothe, Arleden, and 186, these are all the values. So if we want to extract the keys, we use keys. Similarly, if we wanted to extract the values, well, you just type values. So now we're extracting kind of the other half, right? Kvothe, Arleden, 186 instead of first name, last name, height in centimeters. In addition to that, you can do isEmpty. This just tells you whether or not the object is empty. So this object, clearly not empty. There are a lot of things there, right? Is not empty. That's dang right it's not empty. There's a lot going on in there. Next up, we have hasField. HasField is pretty self-explanatory. Basically, we're just looking to see if there's a field called whatever. So maybe we're feeding in an object. We just want to check to see if there's a field called first name. Well, we just go first name. That's true. But what if we wanted to check if there was a full name field? Full name in this case would be false because there's no key that corresponds to full name. Realistically, they probably should have called this hasKey and not hasField, but what are you going to do, right? JavaScript. Okay, great. Next up, we have compact. Compact just does the same thing in objects as it does to arrays. So basically, if we had any empty values here, we could basically remove them instantly. I'll show you guys an example. If I go first name, Nick, then I go last name, and then I go empty, the end result of feeding this in to our compact function, it just removes this last element and field entirely because it's empty. If I put an X there, you'd see it'd populate it. Okay, the next function I want to talk about is going to be called keep fields containing. This is kind of an interesting one because I don't know, they change the name or the meaning of fields over and over and over again. But basically, you see over here how I have first name, quote, last name, Arlen, height in centimeters. Well, what if I only wanted to extract parts of this object that have quoth in it? So I want to extract the field name and the value of the field and value that contain quoth. If I put that in there, you see that I've now created a smaller object called first name quoth, and that's it. I don't really ever use this in practice. And to be honest, I don't use most of the object manipulators in practice, but we have remove field. Remove field just allows you to specifically take things out that you don't want. So maybe we want to remove the last name. We want to remove the height in centimeters, right? We also have remove fields containing. So this will go and take out fields that contain a value that we want or don't want. So in our case, we don't want any fields containing the value of quoth. So we take first name out entirely, and now it's just last name, height in centimeters. And then we have our obligatory toJSON string, which just takes in the object and then it turns it into a JSON string that we can send or receive basically through API call. So, if you're trying to send an API call or trying to send data somewhere and it keeps on telling you that your JSON is misformatted, just try passing it through toJSON string first. I use it pretty often. Last thing I'm going to show you is URL encode. This is pretty interesting, but basically, how earlier we were talking about URLs, right? Let's hypothetically say I have some database available, okay? What you can do in a database is you can encode what are called query parameters. What you can do with a URL is you can encode what are called query parameters. Query parameters look like this. You put a question mark, and then after you put the name of the variable or the key name, and then the value. And if you want to add more, the name of the variable or the key name, and then the value. And name of the variable, aka the key name, and then the value. So what this allows you to do is allows you to turn a JSON object, which is sort of like this structured thing, right? And it allows you to just instantly encode it as one of these URL parameters or query parameters. This is pretty useful anytime you want to send or receive data added to a website or something like that. Because instead of you having to manually put all this stuff out, hypothetically, I could totally go, first name equals, and then I could go $JSON.object.first name, right? It'd be kind of similar. But I'd have to do this sort of structure over and over and over again, which would just be a massive pain in the ass, right? Hypothetically, instead of me doing this, what if I just went, this is, as you can see, it's just really unseemly. Instead of doing this, if I just went JSON.object.URL encode, this is kind of a lot more interpretable, a lot shorter, a lot easier. So I use URL encode pretty often. Okay, let's cover Boolean functions, and boy, do I have a surprise for you. If we go JSON.Boolean.bool, I should say, you'll see that there are really only two functions. There's toNumber, and then there's toString. So toNumber just turns a true into a 1, and then a false into a 0. In our case, what we have is we have a true down here, so the output is going to be a 1, right? If we wanted to instead turn this to a string, this just turns the bool, which is technically, even though this is in letters like TRUE, this technically isn't considered a string. So what this allows us to do is allows us to take a bool and then convert it into a string. So we could do things like, to uppercase or something. If we were just to go bool to uppercase, as you see, it doesn't really allow us to because this isn't like a function that you can apply to bools. So you got to go to string first, basically. Okay, the last thing we're going to be doing is talking about datetime functions. Now, the first thing we have to do in order to get a datetime function is we have to get a datetime, right? So if you guys remember, the way that I did this, in order to get the lux in datetime, it was called, was I went 31/01/2025. Then I went to datetime, saying that it can't convert it. And why was that? I think my format might have been different, actually. 01, was it 01? Yeah, sorry. It was, I think it was 01/31. Yeah, to lux in datetime. Okay, anyway. Okay, so once we have something in the standardized datetime format, there is a million and one things that you can do. All you do is you press period, and now the standardized datetime format offers just, I don't know, 20 or 30 functions. Now, I'm not actually going to show you every single one of these because some of these are such obvious variants of each other. Like you can plus a date, you can subtract a date and that sort of thing. But I am going to cover all the ones that are important that I find myself using pretty often. So the first one's called format. Format is super valuable. Basically, it allows you to get something that is a date time, okay, like this. Then it allows you to format it however the hell you want. So you know how there are millions of datetime formats out there? or millions of date formats. Some people want it year slash month slash day. Other people want it month slash year day slash year. Well, this allows you to do so using characters that are designated in this formatting guide. So basically, you have tokens like S, tokens like lowercase u, tokens like z, tokens like k, right? And all these correspond to things. Like hypothetically, if you wanted to instantly translate any time into an extra verbose localized date time, you could just type FFF, and it would automatically do that. So let me show you. If I just typed FFFF, I've now converted this into a date time, and then I've immediately formatted it into this super extraordinarily complicated looking date, which is just like a string representation. I could remove some complexity with FFF. I could remove even more with FF, and I could just go FF to get some other format. Likewise, I actually create my own format if I wanted to. So maybe I wanted to go year. Okay. Sorry, Y, I meant to say, because you got a lowercase y's. Then month, and then date. And then let's say I wanted to go hour, minute, second. Okay. I've taken this date, and then I've converted it to a date time. Then I've formatted it in this specific structure. As you can see, we end up with not only the year, the day, and the month and the day, we also end up with like the number of hours, minutes, and seconds. Now in this case, it's 000. Why is it 000? Well, I've been inserting standardized date times here. What you can actually do is there's a specific function that grabs the current date and time called $now. So $now, if I were to just remove this, $now is already in a date time. So you actually don't need to convert this to a date time. All you would have to do is you just format this as follows. Year, month, day, and then HMMSS. Or maybe HH, I think, if I want to get 3. And then I think you just go A. No, P. It'd say like AM or PM or something like that. I kind of forget how to do that though. But anyway, now, you can format the exact current time, which is pretty cool and pretty useful. And I believe there used to be, and I don't know if there still are, I think there was like a timestamp variable or something else, but I'll leave that out just for the purposes of this discussion. Okay, great. So if I just go back to my previous example, which just had sort of a simpler look at a date because we didn't have a bunch of seconds and stuff like that. If I press period again, you'll see that now we also have a few options. We have minus, we have plus, and then we have diff2 and then extract. And these are the most commonly used datetime functions and ones that I use basically all the time. Minus just subtracts a given amount of time from a date, and it allows you to designate things just in like natural language. Well, not natural language, but like using dates, days, hours, weeks, that sort of thing. And then plus adds. Let me show you what this looks like. So you know how right now this is like 0000. Like basically there's no, there's not even a single second to the day. Well, what if I wanted to add, 30, then seconds? Well, you'll see we've just changed this here. 40 seconds, 50 seconds, 60 seconds, 70 seconds, 80 seconds, 90 seconds. Let's say hypothetically we wanted to add 10 days to this. Well, now it's February the 10th. How about 10 weeks? Well, now it's March the 11th. Well, now how about 10 months? Well, now it's November the 30th, right? You could even add years. This is pretty standard, right? If you wanted to take this out, you just subtract instead by using minus. So a variety of different functions available to you for just doing like simple date manipulations. A couple of other ones that I use pretty often. There's this one here called diff2. Basically what you do is you feed in, the most commonly used one is now, but basically you feed in the starter over here on the left, and then you get the difference between that and the second date over here, which in our case, we're just going $now. And then we get the number of days. Hypothetically, what we could also do, if you wanted to reverse this, right? This is a negative value. We could go $now, diff2, and then we could feed in this whole thing. And then we'd get that it's been 0.667 days from this, AKA I'm about 66% done on the current day, because this was counting from like the 0th minute, the 0th second, the 0th hour of, January the 31st, 2025. Likewise, we could show this off in weeks. We could do this in minutes. We could do this in seconds. Man, it's kind of crazy to me that 960 minutes have already gone by in my day. What the hell have I been doing? Anyway, aside from the existential value, obviously there's just a lot that you can do and get done. And then we could also extract. So we could extract things from this really easily. Like now is obviously January the 31st, 2025, right? What if I wanted to extract the month? Well, we get the first month of the year. If I wanted to extract the year, what if I wanted to extract the day, right? I can basically go in, I can extract the current second, man. I can extract the minute, right? The minute of the hour of the day. So I have a lot of options available to me. And so this ends up being pretty valuable when, I don't know, usually when I'm sending or receiving something, or when I'm performing logic for stuff like invoice follow-ups or email follow-ups, using all of these functions just makes it a lot easier to calculate how long it's been since something has occurred, and so on and so forth. Variety of other functions. This one is end of. This allows you to round up to the end of the month. So if I were to give you an example, this doesn't really make sense because I'm at the end. So why don't we do start of instead? Startup just does the same thing. It just rounds in the opposite direction. But if I want to round out the, if I want to round out my current date to the start of, then basically what I've done is I've rounded my date, which was January the 31st, to the beginning of the month, which was the 1st. So this is very similar to the floor function. It's just you're technically flooring like a date, which is pretty wild. If I wanted to go start of the year, it'll be the same thing because this is January, right? If I wanted to go end of year, you can see that we're now 2025, 12, 31, 23, 59, 59, 999, so on and so forth. This goes all the way to the very, very end of the year. I don't remember if you could do decade. No, you can't do decade. Can you do millennium? Yeah, anyway. Lux and date time is something for another time. Lux and date times for another date time. If you guys want to check the myriad cool functions, just Google this, and then you'll see a variety of dot functions similar to what we've been screwing around with here. Luxon's extraordinarily powerful, but obviously some of the syntax and stuff like that can be a little trickier. Okay, and then aside from that, there was just a couple other ones that I used pretty often. Oh yeah, they're components. So you know how earlier we were extracting things and we were doing so by saying like month? Well, you can actually just get like day. You can get like month. You can get like year, and you can dot index it that way. There's also zone. So, you know, a lot of the time when you feed in a datetime object that you get from an API or something, it will include stuff like this, -07. Well, what you can do is if you just type in zone, it'll tell you what the name of that time zone is, which can be really useful. You know, just when clarifying stuff, contractual documents can be useful because a lot of services also require you to feed in a time zone. And a lot of these also just use like zone codes, or they I don't know, there's like a lot more names to these zones than I understand. So in practice, I usually end up using something like that in order to reference it. And then there's just some helper functions like isWeekend. So like, you know, you can find out if the date is a weekend. Let's say you're sending some sort of invoice follow-up. Well, you can, you know, do your math, and then you can determine if something is a weekend. And then if it is a weekend, you can grab the date, and then you can add 1 to it or 2 to it, and then you can send it on the Monday instead. You have a lot of options, I should say, which is pretty neat with formatting, you know, date times as things like, you know, whether it's a weekend, or in this case, whether it's a leap year, or so on and so forth. So yeah, I'm going to leave the datetime functions there, but definitely check that out if you guys want a lot more power and control over the way that works. I didn't add datetime functions in the batch of 106 just because these aren't technically like N8N functions. These are functions outside a library called Luxon. And, you know, that's not like native to N8N or anything like that, but obviously they're still super powerful to know, so I highly recommend it. Okay, great. I hope you guys liked learning all 106 N8N functions plus some additional bonus datetime ones. Had a lot of fun putting this together for you. If you guys have any questions about the specific functions that I mentioned, please drop them down below. Understanding this stuff at a deep visceral level really is how you become like an N8N god, so hopefully you guys got a lot of value out of that. And if there's anything in particular that you want me to cover for N8N or just no code or automation in general, just drop that down below as well. I source most of my ideas from my audience at this point. I'm actually doing N8N just because I knew that this would be really important to a large chunk of my audience that was getting a little bit more technologically sophisticated and wanting to start using a new tool. So great example of where that serendipity can lead you. Otherwise, please like, subscribe, do all that fun YouTube stuff for the algo. I'll catch you in the next one. Cheers.